From the beautiful northern studios of Way Happy, this is Mr. Meyer and 2.3 linear equations. Now, what is a linear equation? Linear is a fancy word to say line, right? If you see it right in there, line. It's a dead giveaway. It's the word line. So it means that your data that you have is going to make a nice straight line, and thence we call it a linear function. It has a constant rate of change. If you go out and you run, you're probably running at a different rate all the time. So you're not linear, right? Your speed is kind of changing. But if you could consistently run, we would use a linear model. We would use a line to record your pace. So it just depends on what we are calculating for linear functions. Um, Linear functions mean the data can be shown as a line. So look at example one. We got some data, and there's two ways I could do this problem right now. I could graph it and see if it looks like a line. They're asking me to see if it's linear. So I could go like, hey, negative 2, 2, and I'm a horrible grapher, so this might not be the best way. 0, 1, 2, 0. Hey, this is looking pretty linear. 4, negative 1. Man, does that look like it's making a line? Then you should be able to find the equation of that line if you could. So I'm thinking, yes, it looks pretty linear. And I see the answer there is linear. Another way to tell is it has a constant increase in the x values. They keep upping the x values by 2, which is nice because then I can compare the y values. This went down 1, this went down 1, this went down 1. Hey, if they continue to do the same thing over and over and over again, then you could call it linear. And so therefore I could say that yes, this is linear. So I did it two different ways. One way was I graphed it and checked it out. The second way was that I just checked the rate of change, really. How did the y values change as I looked through this? So same thing with number 2 here, or part B. I might do the exact same thing. I might be like, all right, I'm going to plot 2, 2. Then I'm going to plot 3, 4. All right, that looks pretty linear right now. And then 4, 8. Oh gosh, I probably should have had more room. 4, 5, 6, 7, 8. Okay, that one looks like it kind of just ruined it already. And then 516 is going to be way up here. Yeah, that definitely does not look like a line. So I would say it's not linear. But also look here, it increased by 1 every time. So that was pretty constant. But here it went up 2, and then it went up 4, and then it went up 8. They kept adding huge chunks or multiplying by 2. But to be linear, they have to be adding the same thing every time. So therefore, I can see that this is not a linear function. And I have two ways that I've shown it. Right. So the cool thing is, if something is linear, then we can calculate how quickly the thing changes in the y direction over how quickly it changes in the x direction. And therefore, we can calculate what we call the rate of change. How much does it rise over how much does it run? Oh, is that starting to sound familiar? But it's consistent. It's a constant number. It's a nice proportion, right? I can talk about the proportion of how much it rises, or the ratio of how much it rises over how much it runs. And therefore, we get this thing called the rate of change, or you're probably saying the slope, right? So here you go. The rate of change is how much it changes in the y direction over how much changes the x direction, also known as slope. So with that information, I should be able to graph lines when you give me little information. Like in this A, you say it passes through the point -1, -3. So if I'm going to go graph that, I'm going to plot the point -1, -3. So -1, -3 is right there. And then the slope I see is 5 over 2. That means the rise was 5. So I'm going to, from that point, go up 5. 1, 2, 3, 4, 5. It's right here. And then I'm going to run 2. I'm going to go right 2. 1, 2. And then right there. And I could do that again. I could go up 5 and over 2. I could even do the opposites. Instead of going up and right, I could go down and left and still get lines that are on that point. So there would be the graph of the equation of that line. Yeah, what is the equation of that line if you didn't know? I don't think it's come up yet, y equals mx plus b. I think it's coming up in a minute, but there's your slope, and this is your y-intercept. So I won't say it. I won't ruin it for you yet. We'll keep it as a surprise. All right. What about the next one? They give me a slope and they give me another point. So I'm going to do the exact same thing. Notice the slope is negative this time. And we should talk about that. If you read a graph like you read a book, left to right. So you read it this way. If it's going uphill, it has a positive slope. If it's going downhill, it has a negative slope. So that one had a positive slope, and my graph could show that. This one has a negative slope, so as I read it left to right, I'm going to expect for it to go downhill. So let me plot the point 0, 2. And now it has a negative slope of 3/4. Now you decide where you want to take that negative. Usually I go up and right, but there's a negative here. So, but there's only one negative. So pick which way. Do you want it to go with the up? In other words, do you want to go negative up, which would be down? Or do you want to go negative right, which would be left? I'm going to choose to take it with this guy. So the negative is going to go with that guy, which means I will no longer go up. I will now go down. So I'm going to go down 3, 1, 2, 3, but I will still go right because I've used up the negative. I will still go right, apparently 4, which is way over here. And then I can graph this graph. And so as you see it, this line looks like that. As you see that beautiful graph, you can see that if you read it from left to right, it is going downhill, right? So a negative slope reading left to right should go down, and a positive slope should go up. All right, let me ask you a question, and I'll be right back. All right, nice work. Now, remember from your favorite class, geometry, that 2 points defined a line. You just needed 2 points, and you could draw a line. Now, what if somebody gives you an equation? Could you graph those 2 points? Well, sometimes it's really easy to find 2 very important points called the x-intercept and the y-intercept. Remember on our graph, we have an x-axis and we have a y-axis. Whoops, what did I just do? X-axis and a y-axis. And when you have that, you could very easily find those 2 points when you are trying to find it in an equation. You could plot those 2 points, connect them, and have the line drawn. It's probably one of the fastest ways to graph. It's maybe not the most common, but a very quick one. So let me show you by finding intercepts how I could graph this equation. So here's my graph paper, and you might notice something that when I have up here the x-intercept, you can see that the x-intercept is right here, right? Its y value is 0. Its x value is something, in this case probably 2, but its y value is 0, and that's true for every x-intercept. So if I want to find the x-intercept, all I have to do is let y equal 0. So I would have 4x minus 2 times y, which is 0, equals 16, or 4x equals 16, because 2 times 0 is 0. Divide by 4, x is 4. That's your x-intercept. More importantly, you should write the point 4, 0. You shouldn't just say x equals 4 because that's actually a line. But 4, 0 is a point. So 1, 2, 3, 4, boom. There is your x-intercept. Now, if I want to find the y-intercept, you might go up there and look again. You will notice that the x was 0. So plug it in, make the x 0. You'd have 4 times 0, which is nothing, minus 2y equals 16. You would get negative 2y equals 16. You would divide by negative 2 and get y is negative 8. And if I do that, 1, 2, 3, 4, 5, 6, 7, 8, right there. Again, that's a point 0, negative 8. The y value is negative 8. The x is 0. There's your x-intercept. There's your y-intercept. You have 2 points. You can now draw the line thanks to geometry. And hopefully you go through those 2 points, not like I did and miss. And that's how you can graph using intercepts. Super simple, easy way to graph, super helpful, and very, very nice. Now, let's talk about slope-intercept form. You can see it right there, y equals mx plus b. I hinted to it earlier, but now we're going to use it. M is always the slope, so that's that rise over run. B is always your y-intercept. That's why that was important that we discussed what a y-intercept was. That's where it crosses the y-axis. So in order to graph something, you want to get it to say y equals, and then you can use the little tricks into graphing. I'll show, I guess, that video probably in class. But here we go. If I want to rewrite something to say y equals, and this is pretty challenging, one of the things that some people found hard on the diagnostic test that we did is that you want to get y by himself. So instead of making this say x equals, we want y alone. Anybody who's added or subtracted the y, we want to move them over, like this 4x. I want you out of here. You're in my way. So you're gone. And I have y equals, and then what are you left with on the right side? You're left with 4x minus 1. That is slope-intercept form. I know the slope is 4, and I know the y-intercept is negative 1. And I could graph it. but I won't yet. Oh, it does say then graph the function. Yay! So I didn't think it did, and it did. So I start off at, remember, here's the y-intercept. You start off at -1. That's where you start. And then the slope is how much you rise and how much you run. Now, 4 is just a whole number, so make it a fraction. It's up 4 and right 1. So up 1, 2, 3, 4, and then right 1. That is how you write 4 as a fraction, right? That's a fraction, and that's how you would write the number 4. And so there is your line going through that, and you have now graphed the line. I like to label it 4x minus 1 once I know it. What about the other one? Oh my goodness, that looks scary. I want y by himself again. Get y alone, right? So the first step is going to be get y alone. So I'm going to subtract x from both sides, and you're going to have 3/4 y equals negative x plus 6. Now I'm still trying to get y alone, but a lot's happening to it. So I can either multiply by 4/3, or I'll do it in 2 steps. I'll multiply everybody by 4 first. So if I multiply by 4, I get 3y equals negative 4x plus, is that 24? And then I will divide by 3 and get y equals negative 4/3 x. And then 24/3, what is that? 24/3? Oh, that's like 7. Is that 8? That is just 8. Beautiful. So I will cross that out and put 8. All right, now look what we found. We found what we call the y-intercept and the slope. Remember, the slope is always in front of x. Even if you wrote it out of order, it's in front of x, so be careful. The y-intercept, that's where you start. Start on b, right? 1, 2, 3, 4, 5, 6, 7, 8, way up here. And then the slope was negative 4/3, bent down 4. 1, 2, 3, 4 over 3. 1, 2, 3. 1, 2, 3, 4 over 1, 2, 3. Boom, right there. And there is my graph of y equals negative 4/3 x plus 8. That makes graphing so easy, so nice. All right, let's ask you a question, and I'll be right back. All right, nice work. And now let's talk about vertical and horizontal lines. When everybody starts working with this y equals mx plus b stuff, they get really good at it, and they start doing slopes and intercepts. And I'm super proud of them. But the problem is they forget the easy ones, the vertical and the horizontal lines. The ones that only have a y equals or an x equals. They don't have anything else. They don't have both an x and a y. So if you have both an x and a y, you're going to have to worry about slopes and intercepts. If you have just y equals or you have just x equals, then you're just going to graph a line. And that's nice. So the only thing you have to remember here is when x is equal to another number, it's a vertical line. When y is equal to a number, it's a horizontal line. It should be true for every point. Maybe I'll show you that when I graph one. So let's do this next example that says determine if it's vertical or horizontal and then graph. Maybe I'm going to do it backwards. I'm going to graph it and then decide if it's vertical or horizontal. So sometimes I can't remember, right? So there's my graph paper, and I come walking up and I want to graph it, and x is 2. Well, I know x is 2 right here, but I can't remember. Is it a horizontal line or a vertical line? Well, remember, x always has to be 2, and the y's can change. We just plotted the point 2, 0. So if x is 2, there could be 2, 1, it could be 2, 2, it could be 2, 5, right? Just make sure that the x's are always 2. So where would those points be? Well, there would be like 2, 1, 2, 2, a 2, 5 would be up here. Hey, look, all those points make a nice vertical line. So that must be the line they're talking about, because the only restraint they had was x was 2. Y's could be anything. So I know it's a vertical line, and there's the graph. Same thing here with this one. Somebody might come up to you and say, graph y equals -4, and you can't remember where it is. I hopefully remember it's down 4 and draw a horizontal line. But if I forget, I would do things like, well, you're graphing points x, y, but you can do whatever x you want. Just make sure the y is -4 is what this is saying. So let's see, x could be 1 and y could be -4. So there's my -4. There's my -4. And then x could be 5 and y would be -4. X could be -3 and y would be -4. Notice it's starting to build a horizontal line, and that is y equals -4. And that's what we love. Easiest ones ever, but for some reason your guy's brain goes blank when you see them. So if there's an x and a y, I got to worry about slopes, I got to worry about intercepts. When there's just an x or just a y, I'm got to decide if it's horizontal or vertical, and I can do that by plotting a few points and understanding the restriction that they gave me when they gave me a number. All right, last one. Ski lift carries skiers from an altitude of 1,800 feet to 3,000 feet over a horizontal distance of 2,000. So here you are at 1,800 feet, and I'm going to carry you up to 3,000 feet, right? I'm going to climb that much over a horizontal distance from here to here is 2,000 feet. What is your slope? Well, remember what slope is? It's how much you rose over how much you ran. So it looks like I rose 1,200 and I ran 3,000. That's what it looks like to me. So there's my slope. My slope would be a rise of 1,200. And how would I have gotten that? I would have subtracted 3,000 and 1,800. And I ran, I would have decided how far we went, 2,000 feet. Make sure they're both in feet because that would otherwise be pretty ugly. Let's see, that zero cancels that zero cancels that zero. So reducing this a little bit, I get 12 20ths. Oh, wait, 4 goes into both of those. So 3/5. So there is your slope. It is a rise of 3 feet and a run of 5 feet. So every 5 feet we go over, we have climbed 3 feet in altitude. And that's it. Nice work. Pat yourself on the back. Stay happy, and I'll see you tomorrow.